Okay, so good morning. Welcome everyone to this fourth session of the workshop series Industry Sector of the Month. For this session today, we have the first part on the topic finances and insurance. So today we'll hear from two NCCs, NCC France and NCC Slovakia. And for information, next Monday we will hear from two other NCCs on the same topic. So next Monday we'll hear from NCC Montenegro and NCC Germany. But today, let's first hear from Marie-Sophie Cabot about some use case in NCC France, and then we'll hear from Bosidara Pellegrini about some use cases in NCC Slovakia. Just for information regarding the general organization of the workshop, we'll have the two talks, and then we'll have a global common Q&A discussion session after the talk, and the workshop will last around 1 hour. And without further ado, I will stop sharing the screen, and Marie-Sophie, the floor is yours.
Okay, thank you. So I will focus on two use cases that we had with financial. One is a startup, another one is a SME. We also had some use case with insurance, but I already presented them in a workshop which was dedicated to risks, because their interest for HPC was related to the risk evaluation, so not much of not direct financial things. So the first use case that we had was a startup which was created in 2021, and they contacted us in 2021 just to well, they from the beginning they estimated that the access to computational resources was an important point for them, because they had an algorithm, an AI algorithm, and they wanted to use HPC environment. So what we did with them was to make them get started on the supercomputer, and even get started with Linux and BASH, and also with all the HPC environments. We also talked about job arrays to them. Well, some tools really specific to HPC, and they use it on their own. We made it was at the end it was less than 1,000 core hours which were used by them, but there was 2.5 days of expertise which were provided during half-day sessions to train them, to explain them all the environment and so on. With them, we had the presentation. They accepted to come for a testimony at French Tech in June 2023, and they agreed. We had an agreement for they are well, to make a use case to be in the use case portfolio. So that's interesting for us. The second one is Advestis. Advestis was SME specialized in AI and machine learning. with a specific activity in financial. We signed with them in January 2022, and they wanted they had an algorithm which was based on rules. It's rules concerning, they had the 10 years of data with a lot of features, and they made rules on this data, and they wanted to make the algorithm parallel. So on our side, we had to put the good environment for, they go to MPI, they used MPI for Pi. There were also performance tests, and there were regular meetings with them during half days, also every 2 weeks, to help them in implementing their code in HPC, to help them in analyzing bottlenecks and how to fix these bottlenecks. At the end, there was about 30,000 core hours, and about 4 days of 8 half day of support from our team. We had really a good collaboration with them. There was a scientific presentation with a poster in a French event, which is called GCAD, which is a meeting concerning computation and data. And we had also a common communication in professional fair, which is called Big Data and AI Paris in 2023. This was just after that the SME has been bought by an international group, which is called Mazars. And it was just after this was done in July, and we make the presentation in September. So there was a big interest for this presentation. And this is, we also had some discussions about Dask and another code, but there was no more collaboration. The idea was to put the code on a GPU, but in fact it was not a good candidate for GPU, so there was no more work with them. So I think that's all. Thank
Great.
you.
Thanks a lot, Marie-Sophie, for this presentation. I see already some questions in the chat, so great. But let's keep them for, as I said, the global Q&A at the end. And let's continue now with the presentation for NCC Slovakia by Božidara Pellegrini. Božidara, the floor is yours. Full screen, perfect.
Oh. Do you see my presentation now?
Yes, full screen. Good.
Okay. So good morning, everyone. I'm Božidara Pellegrini from NCC Slovakia. And today I'll present a practical case where we tackled a common data processing issue in the finance sector using synthetic data and natural language processing tools. So this project demonstrates how HPC and domain adapted AI can bring real impact. So the financial and insurance sectors rely heavily on accurate, up-to-date client information. Think of client onboarding, fraud detection, regulations. All of these require correct address data. So increasingly, customer interactions are done through voice bots and chatbots, and especially for things like confirming or updating contact details. These systems use speech-to-text transcriptions, so this introduces errors, especially in Slovak, where we have many declinations and variations. And our use case starts from this pain point. We partnered with Netel. This is a Slovak company developing chatbots and voice interfaces. Their real-world need was simple: how to automatically extract full address information from speech transcripts. These transcripts were messy, as expected. So there was background noise, disfluencies, and inconsistent phrasing. The challenge was to identify address elements reliably. So we set up the goal to build a named entity recognition model specifically tuned to detect parts of an address. In this case, municipality, street, house number, and postal code. So now, what is named entity recognition, or NER? It's a subfield of natural language processing that detects and classifies specific types of information in text. Normally, this includes names of people, organizations, or locations. In our project, we adapted NER to detect address elements, custom tailored to Slovak spoken language. So instead of just finding, for example, Bratislava, it needs to find that Bratislavska 24th Street in Košice is a full valid address as well. This makes NER a powerful tool to extract structured information from informal or unstructured input. Our collaboration with Netel followed a typical NCC industry support model. So we started with a discovery call, mapped out the challenge, and defined the scope together. So the NCC brought technical expertise, machine learning methodology, and access to HPC infrastructure. Netel brought the business problem and example data. And together we co-designed the approach and deployed model training using the Devana supercomputer. This partnership was crucial for fast progress, so we were able to iterate in a structured and transparent way. So here is how we approach the proof of concept. First, we had to recognize that real annotated data was really scarce. So we only had 69 examples, not nearly enough to train a machine learning model. So we chose to use synthetic data. We selected two Slovak language models, Slovak BERT and a lighter Distil Slovak BERT. Both were fine-tuned specifically for address-related NER. We then trained these models using HPC and monitored their accuracy across iterations. So we validated each step by comparing results on real test data. The synthetic data was generated using GPT 3.5 via prompt engineering. We asked the model to create realistic Slovak sentences where a person provides an address. We included hesitations, missing punctuation, and varied formats to simulate spoken input. So then we annotated each token using the biotagging format. We repeated this process 7 times, expanding and improving the dataset after each round. So eventually, we had a dataset of over 11,000 sentences. This allowed us to train a model that performed well under real-world conditions. So the results. Our first model achieved about 67.5% accuracy. After several training cycles and better synthetic data, we reached 93.1% accuracy on real test samples. We use GPU nodes on Devana and Open on Demand to train and debug iteratively. The final model is light enough for real-time integration and is now deployable in Nettles systems. So this shows the value of combining domain-specific modeling, synthetic data, and powerful HPC infrastructure. So here are the main lessons we think are relevant for other NCCs. First, the synthetic data is a viable tool when real data is scarce. Second, rapid iteration, training, testing, analyzing made all the difference. Also, HPC helped us to do this quickly. Next, adapting pre-trained models like Slovak BERT to specific languages or industries creates high-impact results. And lastly, showing quick wins helps strengthen trust with the SME partner. And some practical insights. Even high-quality synthetic data needs human post-editing. So we also faced overfitting due to the small test set, so regularization was a key. Tools like Open on Demand helped keep the SME engaged. They could see results and give feedback early. And overall, we can say that this project shows that even small proofs of concepts, when done well, can open doors for larger, more strategic collaborations. So thank you for your attention, and I am open for questions.
Thank you very much, Rosidara, for this detailed presentation. Great. So thank you to both our speakers, and let's start right away with the Q&A. Thanks again very much to you, Rosidara and Marie-Sophie, for presenting today the use cases for NCC Slovakia and France. That was great to hear. And thanks a lot for this great discussions also at the end. It's always interesting to be able to interact and hear from all your experiences in your countries. With this, I'm just reminding everyone that we will have a part 2 session on this same topic next Monday. So I welcome you to join us again next Monday. And otherwise, I thank you again for participating today, and I wish you a very nice day and start of the week.